So here in the channel, the probability of transmission of 0 is zero point 0.6 and the probability of transmission of 1 is zero point 0.4. And when 0 is transmitted, the probability of receiving 0 is zero point 0.7 and the probability of receiving 1 is zero point 0.3. And when 1 is transmitted, the probability of receiving 0 is zero point 0.2 and the probability of receiving 1 is zero point 0.8. This is the data that is given in the problem. Now to find the probability that 0 is received, we know that the reception of 0 is influenced by both transmission of 1 and transmission of 0. So the probability of receiving 0 can be expressed as a total probability. So the total probability of receiving 0 is equal to probability that 0 is received when 0 is transmitted into probability that 0 is transmitted plus probability that 0 is received when 1 is transmitted into probability that 1 is transmitted. After substituting the values that are already given, we find out that probability that 0 is received is equal to 0.5. Next, we have to find the probability of error. That is the probability that 1 is received when 0 was transmitted and 0 is received when 1 was transmitted. I have solved this using two methods. In the first method, we know that probability of transmitting 0 is zero point 0.6 and in this case probability that 0 is received is zero point 0.7, which means that probability that 1 is received is 1 minus zero point 0.7, that is 0.3. So the error in this case would be probability that 1 is received when into probability that 0 is transmitted, which would be 0.18. We also note that probability of transmitting 1 is zero point 0.4. So in this case probability of receiving 1 is zero point 0.8, which is given. So probability of receiving 0 would be 1 minus zero point 0.8, that is 0.2. So the error in this case would be probability that 0 is received into probability that 1 is transmitted, which would be 0.08. So the total error, probability of error, would be summation of probability of error when 0 is transmitted plus probability of error when 1 was transmitted, which would be 0.26. This is the second method. We know that it is not right if we receive 1 when 0 is transmitted and if we receive 0 when 1 is transmitted. So the probability of error is equal to probability of this intersection plus probability of this intersection. We know that from conditional probability P of R1 given T naught is equal to P of R1 intersection T naught divided by P of T naught, and P of R naught given T1 is equal to P of R naught intersection T1 divided by P of T1. So we can write the intersections as probability that 1 is received when 0 is transmitted into probability that 0 is transmitted, and this intersection as probability that 0 is received when 1 is transmitted into probability that 1 is transmitted. So substituting them in this probability of error equation and filling in the values that are already given, we get probability of error as 0.26, which is the same as the answer obtained from method 1.